says here, it says that AC is equal to AB plus BC. So basically it's saying that the little parts make up the big part, and then same thing with BD. We'll do that in blue, I guess. BD is BC and this right here. So if we need a reason for that, and it's some sort of like the parts of the line, when two line segments add together, they make another line segment. Do you remember any language like that in class?
No.
Okay.
For this one, what I was gonna put down was addition property of equality, but I wasn't sure.
Oh no, so that's why I was asking. Are you, because I wasn't sure if you're still using those, because that is what it is. It is the addition property of equality. Just wanted to make sure you could still use those. So that's what it sounds like. Like sometimes some class would say it's the sum of two line segments, but we'll go with addition property here. Okay, so in the next line, what they're using is the fact that AC equals BD. So you can set the part for AC equal to the part for BT. So that's literally the substitution. Because you're substituting in for both of them in this case.
Okay.
Does that make sense?
Yeah.
And then the last line, you have to figure out, well, how do you go from 3 to 4? Basically the BCs are going away. They subtract them out. So we can just call that the subtraction property. Is that okay?
Yeah. Okay.
So I guess what's nice is they are telling you how many steps there are in the proof. And you're also just being asked to give the reason, at least for these first couple problems.
Mm-hmm.
So if you got all that down, we'll look at the next one here. Given the measure of angle 1 equals the measure of angle 2. It's good to kind of put that into, some sort of symbol. Basically, these are the same. And then it's going a little further. It says that 3 equals 4. And we want to prove that the measure of the whole angle, A to B to C.
Hold on.
Sure.
Can I stop you real quick? Hold on.
Sure.
Thank you. Okay.
All good? Ready to go?
Yes.
Okay, so it's kind of similar to the last one in some ways. I mean, you've got two angles that are congruent, two angles are congruent, and we want the whole angle to be congruent to the whole angle. So our goal in some ways is this last piece here. Okay, so the first one is given. Second one is ABC is angle 1 plus angle 3.
Mm-hmm.
So to me, that's very much like what we did in the previous one. It's saying that the parts add up to the whole. And so to me, that's the addition property again.
Okay, and then the next one would be the sub.
Yeah, because you're substituting for one instead of the other.
Okay.
Now the last one. No, I'm sorry. No, the last one. DEF is 2 and 4. I'm just trying to figure out here what's going on here. It seems like they're missing a step actually, but we'll just assume this is okay. So ABC equals to 2 plus 4. So you're substituting in for 1 and 2, or 1 and 3. 1 becomes 2, 3 becomes 4. So yes, it is the substitution property.
Okay.
And then instead of 2 and 4, they're saying, well, that's really DEF. So that is also the substitution property. Any questions on that before we move to 4? I didn't hear if you said anything.
Oh, no.
Okay, let's move on to the next one here. All right, so it says given angle 2 is congruent to angle 3, prove that we want to prove that angle 1 is congruent to angle 4. Okay, so I think you know where to start here. Obviously that's given. So now we need a reason that angle.
But the given isn't
That's
1
right.
and 2. The given is 2 and 3.
That's right. So why do they do that? So okay, it's odd that they don't put the given first. So good catch on that. So the reason 1 and 2 are congruent are what are called vertical angles.
Mhm.
And that's the same for 3 and 4. They're congruent by vertical angles. And it's a bit of a leap, but they're saying, since they're saying basically that instead of angle 3, I'm sorry, instead of angle 3, because angle 1 is congruent to 2 and 2 is congruent to 3, you can put a 1 instead of 3. That's the transitive property. And it really comes from this line right here. That's how you go from 3 to 1 there.
Okay. Okay.
All right, let's move on to the next one. Get this snipped in here. All right, so it says given angle 1 and angle 2 are complementary. That means that they add up to 90 degrees. So we know that this is a right angle here. We want to prove that XA is perpendicular to XC. So there's a bit of work to do to prove that. The fact that they're complementary is given. If they're complementary, that means that the measure of each angle is when they add up together is 90 degrees. And then that becomes the definition of complementary. So it's like you can't just like say, oh, they're complementary, it's 90 degrees. You have to actually say this. All right, so now the measure of angle AXC, so that's the big angle. It's the measure of the two little angles. And that's where I was wondering if you have to say like angle addition property or just addition property. That's okay. You might check that in class.
Okay. Okay. I don't think I've heard about the angle one.
Okay, so we'll just go with addition there. And then since the lines 3 and 4 since they're given, since 3 and 4 are the same on the left, the right side's what's changing, and they're substituting in 90 degrees for measure of angle AXC. And so that's substitution, because you're obviously substituting.
Mhm.
All right, so now we're almost there. AXC is a right angle, and that's, I guess that's like, I look at that as the definition of a right angle. If its angle measure is 90, then definition of right angle is what's going on here. So we're almost there. The last line is always the prove. And so the last line is maybe the most challenging, because it goes like this. If the lines were perpendicular, then they would meet at a right angle.
Mhm.
It's this idea of this if then. So if it's the reverse, like if the then part comes first, then you use this word converse. Did you hear that in class?
No, I don't think so.
Okay. So this is converse of definition of perpendicular lines.
Oh wait, I think I have.
Okay. And that would be something, to really pay attention to, because it's kind of confusing the first few times that you see it. So again, the idea is like, if they were perpendicular, you know that they meet at a right angle. But since it's the other way around, since it's a right angle, that's why I use this word converse.
Mm-hmm. Okay.
All right, so I think that takes care of that one. Let me get this next one snipped in. Let me get that. I'm gonna grab that picture. Okay. Okay, so that's a little bit hard to see here, but it says angle 1 and angle 2 are supplementary. Really? I guess they are. Okay. So that's your first statement. Angle 1 and angle 2 are supplementary. And that's what's given. Now, the definition of supplementary angles, that means that the angles add up to something. In this case, they add up to 180. Measure of angle 1 plus the measure of angle 2 equal 180 degrees. That's what it means if they're supplementary.
Okay.
Okay, now vertical angles are congruent they're referring to the only pairs of vertical angles. So that's angle 1 and 3, angle 2 and 4. So that means that angle 1 is congruent to angle 3, and then angle 2 is congruent to angle 4. So just kind of those are the only vertical angles that you can see.
And then number 4 says skip this step.
Yeah, why is that?
I don't know.
I don't get that at all, but okay. So the idea is that if so we want to prove that angle 3 and angle 4 are supplementary. To do that, we need to show that the measure of angle 3 plus the measure of angle 4 equal 180. Okay, now since measure of angle 1 is the same as measure of angle 3, that's where they're making the substitution, saying 1 is really 3 and 2 is really 4, and that's where they get this next line here. They're piecing it together. Now the answer here is I guess definition of supplementary angles. Any questions on this?
No.
I think what you're supposed to say here is that the measure of angle 1 is congruent to the measure of angle 3, and the measure of angle 2 is congruent to the measure of angle 4. That's kind of a proper proof. But you know, it says to skip it. Maybe ask your teacher about it. Maybe not, because you're just happy to get it done.
Mhm.
So, all right, looks like we're up to 7. Is that right?
Yeah.
Okay, or skip this step. Is that normal to be skipping?
I don't know. This is like one of our first things.
Okay. All right, so given that BT bisects EBBC, so if it bisects, that means that these angles, angle 1 and angle 2, are congruent. Okay, so that's pretty good, and we're trying to prove that angle 1 and angle 3 are supplementary. Okay, so that's a little bit of a reach, because I don't even know if that's reasonable, but we'll see here. So first one here is that it's given. You can always kind of get that one. So since BD bisects EBC, that means that angle 1 is congruent to angle 2. Angle 1 congruent to angle 2. That's the definition of an angle bisector. So a lot of times the answer is definition of whatever the thing that's in the previous line.
Okay. Okay.
All right, now the fact that the measure of angle 2 plus the measure of angle 3 equals 180, it really comes from the previous line. The fact that angle 2 and angle 3 form a linear pair. So the definition of a linear pair is that the two angles add up to 90 degrees. So that's going to be, again, a definition of a linear pair. See how it comes from the previous line there?
Yeah.
And that's fairly common. So just keep that in mind. I mean, that's you're going to see that a lot when you're doing these proofs.
Would this next one be the same thing?
This one you're substituting in because
Okay.
you're saying instead of measure of angle 2, we're gonna use measure of angle 1, so that's substitution. But then the last one is they're supplementary because they add up to 180 degrees. I would probably go with definition of supplementary angles, or converse of definition of supplementary angles, I guess, because that's more of the what I usually a converse is the last step in a lot of these.
Okay.
All right, so we've got one more. Do you have some other things you want us to work on besides this today?
This is the only thing I have to get done.
Okay, all right. Let's knock it out here. Okay, just get that. So sorry, I lost where it was. There it is. Okay. Because is there a 4 of 4 page? That's why I was asking. So
Yeah.
I only have 3 pages. Let me see. Let me see if maybe I missed a message. Yeah, I've only got the first 3 pages. So if you want to send that over.
Okay. All right, let me get this one snipped in. All right, so it says here angle FEC is a right angle. Okay, so that's this one right here. That's a right angle. And the next one kind of says the same thing, but it's talking about the measure of it. It's saying like it's not good enough to just say that it's a right angle. You have to say that the measure of the angle is 90 degrees. So that would be a definition of right angle. Um, 3 here says that FEC is the measure of angle 1 plus the measure of angle 2. Basically, you just say, oh, well, if I add them up, I get the other one. So that's the definition. I'm sorry, that's the addition property. We said that earlier. All right, and then the next thing here is saying that if it's saying that since the FEC is 90, if you put 90 in, they kind of reverse this in step 4. It should say 90 equals measure of angle 1 plus measure of angle 2, but they're just flipping it. So that is the substitution property. All right, now angle 2 congruent to angle 4. That's kind of an odd one because it's like, where did that come from? If you go to the picture here, though, it is vertical angles.
Um, okay.
All right, so we're skipping 6, but then, but then it's like, well, where do we go from 6? They're saying the measure of angle 1 plus the measure of angle 4 is 90. Basically, they're going from 4 to 7 here. And they're saying
Mm-hmm.
instead of 2, 2 becomes 4 through the substitution.
Okay. Okay.
Right. So then the last one of the complementary, I guess that'd be definition of complementary angles, something like that. All right. So let me grab the last couple here. All right. Let's see if that loaded up. Reload the page. There it is. Okay. All right. Number 9. Okay, so it says the given is that the two angles 2 and angle 3 are congruent. So those are congruent there. And the next one says that angle 1 plus angle 2 equals 180. It should actually say the measure of angle 1 and the measure of angle 2. It's a small distinction there. So but why? Well, they're linear pairs. So whenever they add up to 180, that's a definition of a linear pair. All right, and then like the 3 here it's based on 2. They're saying since they both equal 180, then the 2 pairs must equal each other. And that's substitution. You're substituting in for the 180 in one or the other. We're basically setting them equal to each other.
Is is the next one like addition or something?
It's
Okay.
it's because the 2 is congruent to 3. They're substituting in for this 3 to go to this 2.
Okay.
So again, it's another substitute. You're close. The
Okay.
last one is a subtraction.
Okay.
All right, and then the last one here, 5, which I know they don't have 5 there, but that is the subtraction property. You subtract the 2 out, and angle 1 equals angle 4.
Okay.
All right, so any questions on that?
No.
Okay, so the next one looks really similar. In fact, it's the same. Am I missing something?
Hmm.
So it uses these angle measures, not congruence, but these are almost identical.
I think they're exactly the same.
Okay.
Yeah, they are.
All right, well, that takes care of those proofs. I'm not sure if that was helpful or not, but there was a lot of repetition in terms of, substituting versus adding together.
Mm-hmm.
So is there anything else you would like to work on today?
No,
You don't have any delta math or anything like that that you need to work on?
no, not yet.
Okay.
Okay.
Well, we can stop here, but I'll just ask one more time. Is there anything else you'd like us to work on for today?
No.
Okay. All right. Well, then I guess we will stop here. So let me stop the recording.